All right. So as you can tell from my iPad screen here, the marker board, we have 3 questions to get through today. 3. That's kind of a tall order for Tuesday, so we're going to hopefully get through them. The last one will be probably the most challenging for us currently. It's the parabola, I believe, or it's an ellipse. It's one of the 2 we have to graph. So there's lots of little things we're going to have to recover with that. We do have to draw it, so that's something we got to get some practice on. But yeah, so yesterday we did problems 6 and 7. 7, I believe, was our race format questions. So we got to make sure that you are comfortable with that. And then today we're doing 8, 9, and 10. Those are the problems we're going to be doing today. So 8, 9, and 10, we have 3 problems to get through. As you can see, I'm going to try to post a video tonight. Sorry, it's going to be a late night, so the video won't be on until way late tonight, so it's got to be going after basketball's all over tonight, so it's gonna be a late one. So sorry, if you really want to see that video, you'll have to wait till probably tomorrow or if you're up at midnight or 1 o'clock in the morning, it might be up then. So but yeah, so semester test is Tuesday the next time we're back. So basically the next Tuesday we're back in class. You can see it up here. Monday, this practice guide is due, so keep that in mind. So you make sure you get this practice guide finished, done, complete. It's due on the Monday when you're back from winter break. If you need to study it one more night, take pictures, make a copy over break so you have that. You can use my website because I have all the pictures there, but if you're that person that likes to have the physical one, make a copy of it to yourself. I sent you an email, you can print it off or just put it on a separate sheet of paper. Now, this is something new, and I forgot to warn you of this yesterday. I would like to do a book check the Wednesday after our semester test. Okay? A book check. A physical book. You have your hard copy, has a book cover on it, and I want to see the number. If you're online via Zoom, you'll just hold the book up to the camera, if that makes any sense. The reason why I like to do it once a quarter, I haven't done it yet. I think that's a perfect time for like the Wednesday after the semester test to do something just for a few minutes, just to get it done. So that way over break, you can go find where you put it. So some people just need that extra week to find it. So I'd like to do a book check. I'm going to warn every class of that. That'll be the January 6th, the day after the semester test. All late work is due tomorrow. So if you have any late work in the JMC grade book or anything like that, make sure you're getting. Really weird. Okay. Anyway. But yeah, so late work is due on Wednesday, December the 23rd. And then obviously your semester test is that Tuesday. So yeah, tomorrow is all last day. So make sure you get all that stuff turned in. I'll go through the grade book over break and stuff and start getting stuff updated for you. Questions before we begin? 8, 9, and 10 today. So. All right, let's jump right in. I'm going to flip through these slides real quick. I'm not going to do every problem. I just want you to see them up here. Okay, so number 1, you have to multiply these 2 together. You might have to distribute powers over parentheses. Just make sure you know how to do your laws of exponents so that you can demonstrate that you know how to do it. 2, you have to simplify the radicals, add and subtract them together. Be something very similar to that on test day. 3, you have to tell me the domain, range, x-intercepts, y-intercepts, and indicated values on the graph at any point. It'll be a new picture. Be aware of that. 4, you have to multiply the polynomials together, add and subtract them. It'll be something like that. That one could take a while, all right? If you're foiling stuff together, make sure you're taking your time on that one. 5, you have to know how to factor. This is one that I'm actually worried about out of those first couple days. The factoring usually gets people, just how to break things apart. You need to be able to use this for that race format question. You have to know how to factor. So 6, differential quotient. The formula will be there. We talked about that yesterday. 7 is the race format. I'm going to try to get it so there's more room for you to write your little paragraph. Because I know, like, we did ours yesterday. I used that entire box to write all my little notes to myself, and then you have to go write it. So I might give you a little more space for that. So I'm going to see what I can do formatting-wise to give you more space to write. But again, how I always describe race format, you got to remember, restate and answer the question right in the beginning. For yours, you have to say the graph of the following thing is found by, and then, because that's the question, how do you graph this thing using the 7-step method? So the first sentence should be restating, and then you're going to answer it. On most algebra classes, really easy. It's like, find the value of x. Well, the value of x is blank. And then you go into the reason to why. But what I always do for race format, this is how I think of it so you get total credit, for at least math anyway. You have to write enough that you clearly describe everything that you're doing. So that, how I think of it is, if someone were to walk in here that has no math skill, none, like maybe they're a geometry student and they're not in pre-calc yet, if they could read your work and it makes sense and they could replicate it, you did your job. You wrote enough, if that makes any sense to you. Write it so that somebody else that doesn't know what you're doing could figure it out from your response. And that's the way that I always put it. That way you're writing enough and it's clear. Okay. All right, we're going to start on 8 and work our way to the end, if that makes any sense. 8, 9, and 10. Okay, are we ready to go? Yeah. Okay, let's jump through it. Let's get into this types of problems here, and hopefully this makes sense to you. All right. Okay, we have to long divide the following problems. This one, I picked this one on purpose. It has a lot of missing terms. If you kind of look up here, or look at your little sheet in front of you, we're missing a 0x right here. There is a 0x missing because you have to have all the terms accounted for. And then on the original polynomial, the dividend, the part that goes in the house, I'm missing a 0x, and I'm missing a 0, like the constant in the back. Zero look terrible. Anyway. Okay, so those are the items. I have to add those in there. Before you long divide, you have to fill in those zeros. So make sure you're doing that. And then we're gonna go through it and we're gonna long divide this. Okay, so the dividend. In the house, here's what we have. So in the house, I almost made it look like a square root symbol. 18x to the fourth, 9x to the third, 9x to the third, 3x squared. Okay, and then I got to put a 0x and a 0. I have to have everything accounted for when I long divide. Every term, even the ones that are missing, have to be filled in, if that makes any sense to you. Okay, can somebody tell me what will be written on the outside using that same idea?
3x squared
Okay.
0x plus 1.
Nice. Okay, good. Because I kind of warned you of that, right? So I told you, you got to have these zeros filled in here. So 0x and a 0. And this has to be a 0 here, 0x. Okay, very nice. Good work. Okay, so now let's go through the math here, that how we're going to do this. We have to figure out what are we going to multiply on a 3x squared that makes 18x to the fourth. What do we need to multiply by? A 6x, and it has to be squared. You're absolutely right. So if I multiply by a 6x squared, that will make 18x to the fourth, if that makes any sense. I have to perfectly match it. So I'm going to multiply by a 6x squared. Now, why I'm putting it all the way in the back, I like to line it up with the item that has the same letters. It's not a big deal. You can put it anywhere you want on the top. I just like to line it up above the x squared so I kind of know where I'm at. Kind of going through the math here. So we're going to multiply by a 6x squared, so I have an 18x to the fourth, a 0x to the third, because 0 times 6 is 0, and then it will be a 6x squared, because 1 times 6x squared. Okay, did that make sense where those things came from? It's taking that 6x squared times everything on the outside. That's where I'm getting this part in blue here. Okay, now what's the next step that I'm going to need to do? Subtract. So I'm going to change all the signs, right? I have to change this to a negative, and a negative. You have to change them all. Then you can, subtract or add straight down. I don't know how you want to think of it. I always think of it as like adding straight down, but 18 minus 18, what do we get? 0. 9 minus 0. 9. And then 3 minus 6. Negative 3, x squared. Right? And then I'm going to drop down the next item. You always drop down the next one item. That's how it works. Okay, does that make sense so far? If I haven't lost anybody yet, hopefully it's kind of like, oh yeah, okay. I can do that. Okay, next item. We start all the way over again, so we start fresh. What do we need to multiply on a 3x squared to make a 9x cubed? A 3 and an x. So if I multiply this by a 3 and an x, that will turn it into a 9x cubed. So I'm going to multiply by a positive 3x. So if I do this correctly, and I multiply by a 3x, I'll have a 9x cubed. So that's perfect. They match up perfectly. 3x times 0x is 0x squares. And then 3x times 1 is 3x. Again, how I'm getting these, I'm multiplying that 3x times everything on the outside, what they call the divisor. Now, going straight down here, straight down, I'm gonna have to change my signs before I do that. I almost forgot. I'm gonna change all the signs. So I'm gonna change that to negative, negative, and a negative. 9 minus 9, 0. Negative 3 minus 0, negative 3. 0 minus 3, negative 3. And we bring down the next item, which is 0. So again, I'm just kind of adding down or subtracting. I don't know how you're thinking of it. Okay, and then we start all the way over again. Question?
Can I do that?
Yes, you may. Now, let's kind of walk through the last part here. All right, yeah, let's go back to green. Okay, the last part here, what do I need to multiply on a 3x squared to make a negative 3x squared? Negative 1. So I'm going to multiply by a negative 1. So if I do this correctly, by multiplying by a negative 1 here, here's what we get. We get a negative 3x squared. Negative 1 times 0 is still 0x. And negative 1 times 1 is a negative 1. I'm going to change the signs. I'll change the signs on this bottom row. So positive, negative, positive. And I'm going to go straight down. Again, when I go across, I'm technically subtracting those, but I'm switching the signs. That's basically what I'm doing. Negative 3 plus 3. 0. Negative 3 minus 0. Negative 3. And then 0 plus 1. Plus 1. And that's my final. That I have a remainder. Like there's nothing else I can drop. So this was actually ended up being a remainder. So that is my remainder. So I know we kind of have a weird kind of goofy thing. That doesn't happen very often. Usually the problems we've done in class, they always work out to be nice and pretty because I make up the problems so that they work out nice. But on this particular case, we do have a remainder. Now, what I want to know is how do I write my final answer? How do we write it? What's my final answer after I divided these? Because we have to state the quotient, what the answer is, and then we also have to state the remainder in correct form. So how do we do it? What's my answer going to be?
6x squared plus 3x minus 1 minus 3x plus 1 over 3x squared plus 1.
Yeah. So if you didn't hear that, we write down what the original quotient was, right? This item. Then after it, I think you might have said minus, but you have to add the actual fraction in the back. So technically you're adding it. And the fraction is the remainder over what you divided by. I think, and you can even put the 0x in there, but you have to put it over what you divided by. The divisor has to be on the bottom. That's how you write mixed numbers. And you'll always add that remainder on. So. All right, questions on this one? There was a lot of work there, sorry. All right, let's move on to number 9. We have 2 more to go through today. So it's going to be short and quick and to the point today. All right, so on this problem, there's a lot to do on this question. If you read the instructions, we have to use Descartes' rule of sign. to figure out the potential classifications of all the roots. So if they're positive, if they're negative, if they're imaginary, what are the roots, right? Then we have to list out what the roots are and then check them using synthetic division and actually find the roots and all the remaining ones. This is mixing it's Unit 3's test questions, 2 of the test questions together. So if you go back to your Unit 3, we had one problem that said use Descartes' rule of sign, and we had another problem that said find the roots. I mixed them into one problem, so you have to do it all in one. So hopefully you have enough space here. I tried to give you plenty of space for this one because you need it. Okay, so does everyone understand how difficult this problem's about to get for us? Can you wrap your head around how much work we have to do on this one? There's a lot. Okay, so we have to do Descartes' rule of sign first. If you don't remember how the Descartes' rule of sign works, you have to make those 3 categories: positive numbers, negative numbers, and imaginary. And then we have to list off, what the roots are. So we have to list, kind of, are they positive, are they negative? Make every combination that we possibly can here, so there's a lot. Okay, so how we do positives. What you do is you start in the beginning of your problem, and you bounce from the front number to the back number, and you count how many times did this thing change sign from positive to negative or negative to positive. So on that problem, if I start in the beginning, that's a 3x squared, or a x cubed, and I bounce to the back, how many times did I change sign? Once. It only changed once. So that means you will have one positive number that will work. It is guaranteed one is going to work. The reason why is that you can't go down by evens. I can't go down by 2s. Right? If I go down by 2s, I'll be a negative number, so I don't want to have that. So it is guaranteed the rest of my combinations, one number is going to work. I don't know how many combinations I'm going to need. Does that make sense? It's 1. It's guaranteed 1. So if I'm going to do my list of all the numbers I'm going to be checking, you better check a positive number because one of them is going to work. That's what it's telling me. It's telling me to check positives because 1's guaranteed. I don't know how many 1s I need. I just put 4 of them there. I don't know if I'll need all 4. Okay, so now we got to do negatives. So now how negatives work. You go back to the original problem and you plug in negative x's into all the spaces where there's an x. You plug negative x's into all the spaces where there's x's on that original problem. And you can see that. It's right next to it. And I plug in negative. This is how I check for negatives. If there is an odd power on your problem, an odd power, it will keep the negative sign out front. So this is an odd power, so the negative sign will stay and it will move to the outside. Like that. If it's an even power, this negative sign goes away. So it turns positive. So this is what it's going to end up being. Like that. Because that negative sign didn't go to the outside. It canceled that one out. And then this one, since it has an odd number, has a 1, this power goes to the outside and turns out to a positive 7. And then the negative 4 in the back stayed a negative 4. Does that make sense? I can actually do this problem without having to put negative x's like that. Basically what I'm telling you is write down your original polynomial, and anytime you see an odd power, switch the sign out front. That's the easiest. That's my shortcut to you right now. I'm going to give you that shortcut.
Why was my 7? Yeah.
It was a negative 7, right?
Yeah.
And this was an odd power.
Yeah, but you're negative 7.
What am I doing? Amateur hour in here. I didn't even realize what I just did. Thank you. I didn't realize what I did. I was going to defend my work and I didn't even realize what I wrote. All right. Anyway, yeah, so good catch on that. So now, so again, when you look at your original problem, so I'm going to just give you the shortcut. Here's my original problem, right? So this is the original. I don't need to write this. You can see it on the screen in front of you, but still important that you get to see this. Anytime you have odd powers, just switch the sign. So that was a 3 and that was a 1. Those two switch. That's the easiest way I can tell you. Does that make sense now? Like the shortcut? Odd power switches the sign. Now, what we're going to do is we're going to check. I'm going to check on that same rule that I did earlier. I'm going to start in the beginning and kind of bounce my way to the back and see, did it switch signs and how many times did it switch? So negative stayed negative, it switched to positive, and then it switched to negative. So that's potentially 2 sign switches. Negative, negative, it wasn't a switch. To positive is a switch, and then to negative it switched. So it switched twice. So, so I have 2, and then I can go down by 2's, right? So that could be 2 or 0. So I could potentially have no negative numbers at work here. And it doesn't look like I need to make any other combination, so I think we should be good there, because there's no other options I can make with 1s and 2s and 0s. I think I made them all. Because you do have to like check if you can make other combinations. So you have to be careful of that. Now, how do I know what the imaginary is? What does this row have to add up to be? Has to be 3. It has to be whatever the highest power is. So 2 and 1 already made 3, so this will be 0 imaginaries. And if I add straight across here, what does this last category have to be? It has to be 2, because they have to add up to be your greatest power. So all 3 categories have to add up to be whatever the highest degree was. So it looks like on this problem, I have 2 combinations that could happen. It could be 1 negative and 1 positive and 2 negatives, or it could be 1 positive and no negative numbers at work. So I am guaranteed to have 1 positive. So when I start making my list here, and I have to do that here in a second, I'm going to check for positive numbers basically. Okay, questions on the steps I just did here. Good catch on that mistake I wrote earlier. Any questions before I move on to the hard stuff? I think this is the easy stuff. All right, I took a screenshot of this already. So now the next part here, I have to do the tricky part. Okay, the tricky part is listing out what the possible roots are. How you do this, you use the back number over the front number. So it's a 4, I ignore the negative sign, it's a 4 over 1. So, and what I'm going to do is that's the back number over the front number. You make all the roots of these numbers. So what are the roots to the number 4? What are the numbers that multiply to give you 4? 4 and 1 or 2 and 2. Okay, those are my numbers that can multiply. Those are all my different numbers that can multiply to give you 4. For the number 1 on the bottom, what are my combinations? 1 and 1. Those are the numbers I multiply to give you 1. Nice clean whole numbers. I'm not going into decimals or fractions or anything like that. And now what I do is I set these up where I use the top number over the bottom number, and I make every combination of numbers that could possibly work. So top over the bottom. So it could be plus or minus 1 over 1. It could be plus or minus 4 over 1. Or it could be plus or minus 2 over 1. So I have 6 numbers I have to check from. Now, if there was a goofy number on the bottom, maybe I have to make a bunch of other combinations. So, but these are the numbers that are my potential roots that could work. That would be my x-intercepts. That's what a root is, by the way, if you don't know. Now, looking back at my chart that I've left printed for you, what numbers should I be checking? Positive numbers. One of these positives are going to work, either number 1, number 4, or number 2. One of them is going to work. So, how I check it is you take one of these numbers and you plug them into all the x's. You plug them into all the x's on the original problem. And you see, will it give you 0? Like it's saying on that equation. So, if I took the number 1, and I would do this on a calculator, by the way. I would take the number 1, plug it into the original problem where all the x's are, right? And I'm going to see, will it give me 0? So, 1 cubed, I'm just going to type this in my calculator, minus 2, minus 7, minus 4, right? So 1, minus 2, minus 7, minus 4. That gave me negative 12, so that definitely didn't work, so definitely not that number. So not this one, not 1. If I check 4, so I'm going to do the same thing, but I'm going to plug a 4. 4 to the power of 3 minus 2 times 4 squared and then 4 squared, and minus 7 times 4, and then minus 4, right? So that's putting 4s into all those locations where the 1s are sitting. Hopefully I typed that in correctly. That gave me 0. 4 cubed minus 2 times 4 squared minus 7 times 4 minus 4. And this actually gave me 0. So check. 4 is the number that I needed. Questions with how I check that really fast? Now, I do need to find all the remaining roots. So here's what I do. Now that I know the number 4 works, and again, I wouldn't be writing that down. I'd just be doing it on a calculator really fast to figure it out. I'm going to synthetic divide the 4 out. The 4 worked. And notice I put the 4 in the box. For synthetic division, what numbers go across the top? What numbers do I write here, 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 and all the way across?
4, -2, -7, -4.
Yeah, it's these numbers. You're absolutely right. It's these numbers that were on my original problem. So 1, -2, -7, and -4. It's those leading numbers on my original problem. That's where I'm getting those numbers from. Now, how this works, because I know some people tend to forget, you have to add straight down. So that's the number 1. You multiply by the number in the box. So 1 times 4 is 4. You add straight down. You multiply by the number in the box. You add straight down. You multiply by the number in the box. You add straight down. And sure enough, it gave me a remainder of 0. This is the remainder, by the way. The last number is always the remainder. That's what we wanted, right? We wanted the remainder to be 0. Okay, I'll stop there. Sorry, I'm going really fast. I don't mean to. I just kind of get going. Any questions with how I did that? Yes, please.
If you were missing like the 7x, would you have to plug in 0?
Yeah, on synthetic, you're absolutely right. You have to plug zeros. So yeah, so if you didn't hear that, that's a great question. If I was missing any of those letters, the variables, like x squared or an x, like you said, you have to fill in zeros on this part right here. So you'll have to have a 0 like x, let's say, or 0x squared. You have to fill those in. If you leave those off, you'll get a really bad mistake. So, yes, good question. Because you have to do it in long division, you have to also do it on synthetic. Yep. Good question. Anything else? It's a really good reminder. Okay, now, the thing that's left here is the remaining function. It's the remaining roots. This thing represents 1x squared, 2x, and a 1. That's what those numbers represent. It's a polynomial. They're the leading numbers on your polynomial. And how I know it's that, it builds up. It's the constant in the back and it builds up. X squared, x cubed, and you just keep going if you have more numbers. So I just start in the back and work my way forward. And so what you can do is you can factor that thing apart. This thing is factorable. X squared plus 2x plus 1. How do I factor it? What am I? Yep, plus, and what is it? X, and 1, and 1. Good, thanks. You went too fast. And so my remaining roots on this problem, what are the numbers that represent these parentheses? -1. And -1 is a double root, it repeated. So, in fact, we did have 2 negative numbers, technically, that worked. -1, -1. Just tap the microphone. If you're going to watch this video later, I wouldn't have headphones on. I just hit the microphone. I'll send vibrations through your skull today. Okay, questions on number 9. Good comments, good questions earlier.
Write down like x equals -1 or
Like this stuff? Oh, yeah, so off to the side, I would just kind of listed what my roots are. So we had -1, -1, and we also had a positive 4. These are the roots. Like, this is the final thing that I want to see. I want to see... What?
Do we need both?
No, you can just have one listed. Yeah. So as long as you have them listed somewhere, these are my roots. This is the whole point of this problem. Is like, what are the roots to this problem? That was the whole goal, right? Is those 3 numbers. You may only find one that works. That's fine. You might find two that work. Great. But you should be able to factor. It will be factorable in the end. I'm going to make that problem so it works. All right. We're good? It's a lot. I know. I said today is kind of a big day. Today was the day we're going to spend a lot of time doing notes. Okay, I'm going to take a screenshot of that first. Okay, last question. So now we're jumping back into ellipses. All the remaining 3 problems, if you look at your practice guide, they're all graphing. It's ellipses, hyperbolas, and parabolas. As quick as I can do it. All right. Anyway, let's go through this in graphing. Where's the center to my ellipse? Say it again. -3, +2. It's the number with the x, the number with the y. Perfect. -3 and +2. There's my center. Okay, that's good. Again, it's the number with the x, number with the y. What is the number below the y, right? There's supposed to be fractions there. What's the number below that?
1.
A 1. So you can always put a 1 down there. So I just happen to have those numbers. Okay, we got to do major and minor axis. Let's do the major axis first. Which one's the major? Which number is bigger? First one. And it's not because of the top number, it's the bottom number right here. That's a major axis. That's how I know which one is my major. It is the square root of 9. The square root of 9 is 3. So that means I'm going to go 3. Now, do I go up and down or right and left? Right and left. Now, why right and left? Has the x above it, right? You have to look at the letter above it. The number or the letter above 9 was an x, so I'm going right and left. So 3 right and left. So boom and boom. Now, if you want to write those coordinates down, I actually want those. That coordinate is 0, 2, and what is that? 1, 2, 3, 4, 5, 6. So -6, 2. So those are my major axis numbers. Those are the coordinates for it. Minor axis. Well, what's the bottom number? What's the smaller of the 2 bottom numbers? 1. So we have to take the square root of it, which is 1. So I'll go up and down 1. Because again, how I know it's up and down, it's above, the y is above it. So I'm going up and down. So what are the coordinates there? Is that -3, 1 and -3, 3? Those are the coordinates where I'm hitting. I can draw that if I want. Okay, there's my ellipse. And now we still have to find the foci. Okay, the foci formula, if you don't remember. Foci for an ellipse. A squared minus B squared equals C squared. It's almost the Pythagorean theorem. It has minus sign though. That's the only difference. Alright, so which one's my A and which one's my B? Yeah, the X and Y number, right? So it's the 9 and 1. So 9 minus 1, which is 8. And we have to take the square root of that, because that's how I solve for C. Right, you take the square root of the other side. So the square root of 8, which is that 2.8, roughly? 2.9? Yeah, 2.8. So 2.8 over, 2.8 over. And again, it's how I know where the foci are located. You can see my dots I threw in there. They're always located along the major axis. So my major axis is going right and left. So if I add that to the center or subtract it from the center, here's what it looks like. It's the center, and I'm adding that 2.8 to it, or I'm going to subtract it.
Would you do the plus minus sign?
Yeah, that's fine. You can do that one. So, and I don't need to have the exact coordinates, but as long as you see the graph and I have those kind of written to the side, you can even just put square root of 8. I'm fine with that instead of 2.8. Questions? All right, there you go. Kind of that was a pretty challenging problem. That's one that you had to kind of remember how we did those. So. I'll guarantee number 10 will be set up in that form. It'll be in nice standard form like that, where you can just immediately go to the graph. The later ones will not. You'll see the ones we do tomorrow, you have to complete the square to them. So the last two. Tomorrow we have 2 problems left. We have a 26-minute class tomorrow. Be careful. We're gonna use a lot of that time, so you got to be in here ready to go tomorrow. Over break, study this stuff. Watch the videos. Study this over and over. You have to be able to take this test in one class period, because I leave Tuesday at like 2 o'clock that day for JV basketball. So you have to be able to take this in one class period and finish it. You can't finish it later. So you have to study this thing to the point where you're super efficient at each problem. You know exactly what you need to do and how to do it. Okay? All right, questions though. All right, that's it for today. So I don't know if I took a screenshot of that one yet. Better take it again. All right, there you go.